Okay, guys, so I want to apologize first. I know a lot of you guys have been kind of waiting on me to update the Datsun Roadster. So, first, I got to apologize, man, but you guys have to understand that this is my personal car. I do this stuff for a living. You know, I can't just be working on my car and not working on other things and not making money. But with that being said, here is our quick and easy test here. So I found out that this was threaded incorrectly. This is supposed to be BSP, but my car was threaded to, like, I believe it was 1/4 inch. So anyways, I have some adapters here, and keep in mind all these hoses are wrong. So these are push-off fittings. I just threw regular hoses on it just to get it going, and they basically come from each runner, and then they come into this goofy little Y block here, and then it runs out to this hose here. So what I want to talk about is idle control for a second here. What people don't realize a lot of is that an idle control really is a controlled vacuum leak. That's all it is. So the valve will go here, and basically it'll open and close based off what we need for idle. So it's definitely not tuned for it, obviously. So what I'm going to do is I'm going to get the car started, and I'm going to plug the hole, and then I will move my thumb here so you guys can, and to essentially simulate the idle valve. So here the car's running, and I'm slowly uncapping this, and you can hear that the idle is changing. Close, open. So as the car is cold, the idle valve will give it more air to allow it to warm up. And as the RPMs come in line, and so does the temperature, the valve will eventually close, and then it'll come to its normal idle. So now that you guys see how idle control is going to work, this is essentially what we're using, and this is your common Ford valve. This is a PWM, pulse width modulated. So I want to talk about operation of this valve. So on Ford valves, there's actually two styles of Ford valves that have got two ports. One that's normally open, and then one that's normally closed. So meaning that if it's normally open, when you power these wires, it should shut the valve. And vice versa. If it's normally closed, when you power this valve, it'll open. So on the normally closed valves, you have to have good idle or good vacuum, and the reason is that because vacuum is actually what holds the valve closed. This one, I believe, is a normally closed valve, and on a normally closed valve, you still have a little bit seeping in because you have to have it seeping in to help with the idle. Alternatively, you could crack the throttle, but normally you have a little air seeping in. So I'm still not sure which valve we're going to use. Now, on my own personal car, it does seem to have really good vacuum, as far as I can tell anyways. On cars that do have a hot cam, the vacuum may not be as good. And honestly, it's far better to have the one where it's normally open and vacuum closes it, just because that it is a more reliable idle valve. But realistically, I mean, it's a Ford, guys. You're going to find these all over the place, especially on the side of the road, Hopefully you guys get that joke. But anyways, so that's essentially how this is going to work. We've got one hose in, one hose out. Now the problem is that on the hose that comes out, normally it goes into the air filter. Obviously on ITBs we are not going to have an air filter, so we may just run an external filter on this if the car is boosted. So if this one is the one for the intake manifold, this would actually go into your intercooler piping before the throttle body. But obviously we're not boosted, so we may just throw a small little PCV style filter on this. We may have to add a inline check valve as well, but it's one of those things that we will have to get to when we get there. The next thing too is wiring. So on these, polarity does not matter. However, what does matter is that you have to have a flyback diode. And so the way a diode works is that it is essentially just a electronical check valve. It stops power from flowing one way, and you just need to have that. I'm not really sure the odds and ends why, but you do need to have it. I can't think of any ECU that can control an idle valve natively without a flyback diode. Now you may not have to wire it up because it's inbuilt onto the board, and it would specifically say that, hey, this board is designed, you know, this output is designed to have a flyback diode. And so anything that switches, boost controller, idle air control valve, anything that's PWM really needs a diode in place. Boost controllers, you can usually kind of get away with them because they don't really flow that much power through them, but idle valves are a completely different story. So the next part is once we get this all hooked up, the hardest part, I think, is always mounting everything. For now, just like the rest of my car, I'm just testing with it, so we're not too worried about that. We're just gonna slap everything all over the place. So I just wanted to give you guys an update to show you that, yes, 1, I am still alive, 2, yes, I still have the Datsun, and 3, I am relatively still working on this thing.